Our next presenter is Hooman Ansari, whose title is Pacemaker Energy Harvester. His advisor is Dr. Amin Karami in the Department of Mechanical and Aerospace Engineering. He loves turtles, or maybe he only likes them, I don't know. He used to play table tennis professionally. I've got to find out more about that. And he's cracked his head 3 times. So, with that all said, ready, set, pitch.
Hi everyone. Today I'm going to talk about energy harvesting for pacemakers. But before I start, I'm going to ask you 2 questions. So by raise of hand, how many of you know what a pacemaker is or have some idea about pacemakers? Great. And the second question is, how many of you have pacemakers or know somebody who uses pacemaker in their body? Cool. Okay, so for those of you who might not be familiar with the subject, pacemaker is a device, implantable biomedical device, that is implanted inside the body of the patients who have heart problems such as arrhythmia. It helps them to have a better life. About 3 million people worldwide, they use pacemakers, and 600,000 surgeries are done each year for placing new pacemaker inside the body of the patients. From this number, about 1/3, which is 200,000 surgeries, is for replacing the old pacemakers. And now you might wonder why such a sophisticated device needs replacing. And the answer is with their battery. Like any other devices that depends on battery, after a while the battery dies out and the patient needs to do a surgery. This time varies from 7 to 12 years depending on the activity of the patient and the age of the patient. The surgery, the new surgery, is costly and also has its own risk. The cost of the surgery is between $20,000 to $90,000. And also the risks are associated with the surgery includes heart infection, which is a serious problem for old people. So now the solution that I've been looking into for the last 3 years for my PhD is an energy harvester. Our energy harvester is going to replace the battery inside the pacemaker. It's going to get the vibration from the heart and convert it to the electricity needed for the pacemaker. So by doing so, the patient doesn't need to do a new surgery since our device is self-charging. Our device is small and also is MRI compatible, which means that the patient can do MRI while has this device inside the body. During my PhD time, I published several journal papers and conference papers, and our team has 2 patents on this subject. Last summer, with the collaboration of University of Michigan, we did the first animal test on the energy harvester while we attach the energy harvester to the heart of a sheep. And hopefully in the future, near future, we're going to have our energy harvester inside the commercial pacemakers in the market. Thank you guys for listening.
Thank you, Hooman.